The train stopped halfway up the grade, not suddenly, not with violence. It simply ceased to climb. The wheels turned once more, then slipped. The engineer released the throttle. Steam vented softly into cold air. Behind him, 16 loaded cars pressed downward against the couplings. The grade was 1 in 40. The curve was tight. The track clung to the mountain face with nothing below but empty space. He reached for the reverser, and that was when the silence changed. The line had been open for 11 years. It crossed the eastern range through a series of switchbacks and climbing curves, connecting the valley mills to the high timber camps. Trains ran twice daily in summer, less frequently in winter. The grade was steep but manageable. Engineers knew the route. Dispatchers knew the loads. Nothing about this morning suggested difficulty. The locomotive was a 10-wheeler built for mountain service. Solid frame. Good boiler. Sufficient tractive effort for the grade if steam was kept up and sand was available. The engineer had made this run 200 times. He knew where to add coal, where to expect wheel slip, where the track leveled briefly before the final push to the summit. Behind the tender came 16 cars. Lumber mostly, some hardware, 2 passenger coaches at the rear. The total weight was within limits. The schedule allowed time. The weather was clear. Everything was routine. They entered the mountain section at 8:43. The grade began gradually, then steepened as the track curved left along the rock face. The locomotive leaned into the climb. Steam pressure held steady. The wheels gripped. The train ascended at 12 miles per hour, then 10, then 8, normal for the grade. At the 4th curve, the engineer added sand to the rails. The wheels bit and held. He opened the throttle slightly. The exhaust sharpened. The train continued upward. Then the wheels slipped. Just once. A brief loss of traction corrected immediately. He reduced throttle, let the wheels recover, then tried again. They slipped again. He applied more sand. The wheels caught, turned halfway, then slipped once more. He closed the throttle. The train stopped moving forward. Steam pressure was adequate. The gauge read 130 pounds. The boiler was hot. Water level was correct. The valves were functioning. There was no mechanical failure. The locomotive was producing power. The wheels were simply unable to transfer that power to forward motion. The rails were dry. The sand was flowing. But the grade was steep, and the curve was tight, and the weight of 16 cars was pressing down through the couplings, loading the driving wheels unevenly. The locomotive could produce thrust, but not enough to overcome the combined resistance of gradient, curvature, and mass. The train had stalled. The engineer sat motionless for several seconds. He could feel the weight behind him. 16 cars, 60 feet each, nearly 1,000 feet of train, all of it pressing backward and downward along the curve. The couplings were compressed. The slack was gone. Every car was bearing against the one ahead. He looked at the grade stretching upward, 200 yards to the next level section. From there, the climb eased. But those 200 yards were the steepest part of the route, and the train was no longer moving. He could not go forward. So he would go back. Reversing a stalled train was not unprecedented. Procedures existed. If a locomotive could not continue upward, it could back down to level track, build steam, and attempt the grade again with better speed or lighter load. Engineers had done this before. It was embarrassing but safe. He moved the reverser into reverse position. He opened the throttle slightly. Steam entered the cylinders in the opposite direction. The wheels should have turned backward. The train should have begun to descend. It did not move. He increased throttle. The wheels spun briefly, then caught, but the train remained stationary. He could hear the steam working. He could feel the locomotive straining, but nothing was moving. He released the throttle and sat back. The fireman looked at him. "Brakes," the fireman said. The engineer checked. The independent brake was released. The automatic brake was set for running position, not emergency. The air pressure in the train line was normal. The brakes were not applied. But the train was not moving. He tried again. This time he released the automatic brake entirely, ensuring no brake shoes were touching the wheels anywhere in the train. He moved the reverser firmly into reverse. He opened the throttle wider. The locomotive shuddered, the wheels turned, the train rocked slightly, then stopped. He could feel resistance, not the resistance of brakes, something else. The train was being held in place by forces that were not mechanical, or rather, forces that were mechanical in a way he had not expected. Gravity was not letting go. The realization came slowly. The train was on a curve, a steep curve. The couplings were compressed. Every car was pressing against the one in front of it. When the locomotive tried to reverse, it was not simply pulling the train backward. It was trying to pull the entire weight of the train around a curve, uphill, against the direction the grade wanted everything to move. The couplings resisted. They were designed to push and pull in straight lines. On a curve under compression, they locked at angles. The knuckles jammed. The cars could not pivot smoothly. Reversing required the couplings to transition from compression to tension. But the weight of the train, combined with the curve and the grade, prevented that transition. The brakes were behaving strangely as well. When the train was moving forward, the brake shoes engaged predictably. But in reverse, on a descending grade, the shoes loaded differently. Some grabbed too hard. Others did not engage at all. The brake rigging, designed for forward motion, responded unpredictably when forces reversed. The engineer tried once more. He opened the throttle further. The drivers spun, caught, then stalled. The train rocked but did not move. He could hear metal groaning. The couplings were loading in ways they were not meant to sustain. He closed the throttle. The train was stuck. Not broken, not derailed, simply unable to move in either direction. Forward was impossible because the wheels could not grip. Backward was impossible because the train could not reverse its own weight on a steep, curved grade. They were suspended between two states, neither climbing nor descending, held in place by geometry and force. The explanation would come later, after engineers examined the site, calculated the forces, and reconstructed what had occurred. The grade was 1 in 40. For every 40 feet of track, the elevation increased 1 foot. That ratio produced a gravitational force pulling the entire train backward with thousands of pounds of pressure. On level track, that force did not exist. On moderate grades, it was manageable, but at 1 in 40, the force became dominant. The couplings were not designed to reverse that force smoothly. When a train moved forward uphill, the couplings were in tension. Each car pulled the one behind it. When a train descended, the couplings transitioned to compression. Each car pushed the one ahead. But on a steep grade, that transition was not smooth. The weight of the train created a compression load so intense that the couplings could not release. They locked. Reversing required breaking that lock, and the locomotive alone could not generate enough backward force to do so. The brakes complicated everything. The air brake system relied on pressurized air flowing through the train line to release the brakes. When pressure dropped, the brakes applied automatically. This worked perfectly in normal operation. But on a steep descending grade, the weight of the train created uneven pressure distribution. Some brake cylinders received full pressure, others received partial pressure. The result was inconsistent braking. Some cars held, some slipped. The train could not move smoothly in either direction. The curve made it worse. Couplings on curves operated at angles. Under compression, those angles caused binding. The knuckles jammed against each other. The train could not flex. It became a single rigid mass, locked in place by its own weight. The wheels added the final constraint. On a steep grade, the driving wheels of the locomotive carried uneven load. When moving forward, weight transferred to the rear drivers, improving traction. When reversing, weight transferred forward, reducing traction on the drivers that mattered. The locomotive could produce power, but the wheels could not hold the rails. Every system was functioning correctly. Every component was within design limits. But the combination of grade, curve, weight, and direction created a condition the designers had not fully anticipated. Some movements, once begun, could not be undone. They waited. A locomotive was dispatched from the valley. It climbed the grade from below, coupled to the rear of the stalled train, and pushed. Slowly, with controlled force, the two locomotives moved the train backward down the curve until the grade eased and the couplings could release. The train descended to the valley. The ascent was not attempted again that day. The route remained open. Trains continued to run, but procedures changed. Loads were calculated more carefully. Speed entering the grade was increased. Engineers were instructed not to stop on the steepest curves. If forward motion failed, they were to apply brakes immediately and signal for assistance. Reversing was no longer considered safe. The explanation spread quietly through the engineering departments. Gradient geometry, coupler mechanics, brake behavior, the interaction of forces that seemed simple in isolation but became complex when combined. It was not a failure, it was a lesson. Some decisions, once made, are difficult to reverse. Some movements, once committed, can only continue forward. Stopping does not mean control, it only means the forces are balanced. And on a mountain grade, with 16 cars pressing downward and nowhere to go but up or down, balance is not the same as safety. The train stopped halfway up the grade. And for a long moment, no one knew what came next.